Friends, in my previous lecture I have completed single reinforced section and double reinforced section. Okay, so design of single reinforced beam, design of double reinforced beam we have completed till last lecture. Okay, so in today's lecture we are going to focus on the L and T beam, how to design L beam or how to design a T beam. So now what is mean by L beam or what is mean by T beam? So actually L beam and T beam concept is concept which is brought for the design purpose. It is brought for the design purpose. Now see, when you cast a beam and slab, generally for the construct, if you look at the construction of RCC frame building, now first we construct a foundation. First we cast the foundation, then your stub column, then your plain beam will be there, then from again column, then on the top of column there will be beam and slab. So now out of that we cast foundation separately, then stub column, then construction of plain beam is done separately, then column. But the casting of beam, that is floor beam and slab, is done simultaneously. Means it is not that first we cast the beam and then we will cast the slab. So common practice is not like this. So we construct or we cast, we pour the concrete in beam and slab at the same time. So as a result of this, what happens? Beam and slab acts as a single unit. It's a monolith construction. Now to take the advantage of that monolith construction or to take the advantage of slab and beam as acting as a single unit, we design a beam as a L beam or a T beam so that our economical design will result, our section will be more effective, our section will be more economical. So now what is mean by designing beam as a T beam? So in that case what we'll do, we'll construct the slab as a part of beam. We consider the slab as a part of beam and we'll design the beam. Okay. Generally in beam, if you see in flexural condition, a top portion of the beam is subjected to compression and bottom portion of the beam is subjected to tension if there is a sagging bending moment. Now, so in the top portion of the beam there is a compression. So now when we are considering the slab portion as a part of beam, we will consider that slab to take the compression. So to take the compression we will consider the slab portion as a part of beam. Means for compression we will consider the slab. Means for to take the compression, slab will be acting as a responsive unit. Okay. Now what will happen? There is compression, there is a tension, and some part of the compression is taken by the slab and remaining part will be taken by the beam. Now in that case definitely some load is reduced or some load is taken by the slab. Definitely the section of the beam will be reduced and it will be more economical. Okay. Now see, I will explain it diagrammatically. Suppose this is a plan, a floor plan of beam. So these are the corner beams and this is the middle beam. Okay. Now if you take the section of this, you will get figure like this. Okay, this is the slab and this is beam. Okay. Now this corner beam will act as L beam. If you see the shape of this corner, this will be L beam and this middle beam will act as a T beam. This is again corner beam, it will act as a L beam. So now, actually the procedure of design or the procedure of construction will be same everywhere. It's not that T-beam means I am going to construct the beam as a T-shaped beam. The shape will be T here, considering this slab. Okay, but the concept of T-beam and LA beam is considered for the design purpose. It is considered for the design purpose. Now what I am going to do here, I will consider this slab portion. I will consider some slab portion as a part of this beam. Okay. So if I put it separate, this will look like this. Now what will happen? See, we know that in a beam, top portion is subjected to compression and bottom portion is subjected to tension. Now this top portion over here is inclusive of slab portion and beam. Now definitely this portion will take a compressive load, and below the neutral axis there will be a tensile load. So means some part of a compression will be taken by this slab portion. So some load is reduced due to the slab. So definitely the resulting section of beam, will be more economical as compared to rectangular beam. Vice versa, if I didn't consider this slab portion, I will consider only beam portion like this. This is my beam. Okay, so I am not going to consider this slab. I am going to consider only beam. Okay, so now the width which is available to resist the compression will be only width of beam, width. And here the width available is more than this width. So definitely as the width is reduced or width is less, definitely depth of beam will increase, because the moment of resistance, bending moment which is going to be act on this beam will remain same in case of rectangle and T-beam. But the responsive factor over here, as the depth width of beam is increased, definitely you will get the benefit in the depth. So depth will get reduced in case of T-beam. Okay. So this is why in actual practice we will design the beam as a T-beam. If it is middle beam, if it is corner beam, here this corner beam will be designed as a L beam. This corner beam will be designed as a L beam. Okay. So in previous lecture, in our previous lectures, we have seen design of single reinforced section, single reinforced, double reinforced section, but we have considered only rectangular beam. In actual practice, when we are going to design, we design it as a T-beam or L-beam. Any beam in a RCCB frame structure, we design it as a L-beam or T-beam to achieve economy, to obtain most effective section, Okay, if you are not bothered with the economy, you can go for the rectangular section, no issues. But design with this T and L type consideration will be more effective, more economical. So now one more question arises over here is, what will be the width of this beam? Means width of this flange. Now see, when we are going to consider this slab portion as a part of beam, this will look like a T-beam, and if you see the components of this T-beam, this is called as a flange, and this is called as wave. This top portion is called as flange, whereas this is called as, this is your flange and this is your wave. Okay, so this width of flange is referred as BF, width of flange, and this is referred as BW, that is width of wave, width of wave. Now see, ये विड्थ लेना कितना है, ये विड्थ लेनी कितनी है, means what will be the width of flange. The slab is extended at the bottom, at the up to the boundary of the slab. So if you see here, the slab is ended over here and the slab on the other side is ended over here. So what will be the width of flange? Okay, so what should be width of flange? We have to take, so there is an IS 456 recommendation, IS 456 1978, that the width of flange is taken as, width of flange is nothing but your slab width, which we have to consider for the compression of about the part of this beam. So this is taken as L0 divided by 6 plus BW plus 6DF. This is for T beam, and L0 divided by 12 plus BW plus 3DF. This is for L beam. L0 divided by 6 plus BW plus 6DF for T beam, and L0 divided by 12 plus BW plus 3DF for L beam. So up to this flange width, up to this width you have to consider that part as a part of beam. Means this width of flange you have to consider, you have to calculate by using this formula. And this should not be more than center to center distance between beam. This should not be more than center to center distance between beam. So suppose the center to center distance between beam is, let us say, 5 meter, then this BF should not be less than, more than 5 meter. It should be less than 5 meter. Okay. So this is how you can calculate BF for the T beam and for the L beam. Now when we are going to consider T beam, when we are going to consider L beam, see, if the beam is a corner beam, definitely there is no slab on the other side of the beam, so definitely it will act as a L beam. And if the beam is middle beam or intermediate beam, not middle, if it is intermediate beam, then definitely it will act as a T beam. It will act as a T beam. And which IS code permits a design of L and T beam. Initially the beam was designed as a rectangular beam, but in 1978, IS 456 1978, जब IS 456 का रिवीजन हुआ था 1978 में, तब उन्होंने ये परमिशन दिया था, you can design a beam as a T beam and L beam. If your exam is MCQ based exam, so there may be a question that which IS code permits you the design of T beam and L beam. So it's IS 456 1978. So 1978 से हमें permission मिला. So what is the effective flange width? L0 divided by 6 plus BW plus 6DF for T beam, and L0 divided by 12 plus BW plus 3DF for L beam. So you can design this L beam and T beam from both the method, that is from limit state method and from working stress method. So in first case today we are going to see, or in next lecture we are going to see how to design this T beam or L beam by using a LSM method, limit state method. Okay, thank you. For today's lecture we will stop here, and in next lecture we will see how to design this L beam and T beam by using limit state method. Thank you.